So today we are going to see some problems regarding linearly dependent and linearly independent. So first we can see the problem is 0, 0, 0 and 2, 5, 3 minus 1, 0, 6. Without doing any steps, here we can say this vectors is a linearly dependent. So a result is there if any one of the vector is a zero vector, then you can say that set of vectors is a linearly dependent. So here you can see the one of the vector is zero vector. Now the second one is 1, 2, 3, then 4, 1, 5, minus 4, 6, 2. So we have two methods to do this problem. One of the method is alpha 1 v1 plus alpha 2 v2 plus alpha 3 v3 is equal to 0. So alpha 1, the first vector is 1, 2, 3. The second vector alpha 2 into 4, 1, 5. And the third vector alpha 3 into minus 4, 6, 2 is equal to 0. And from this way you can write alpha 1 plus 4 alpha 2 minus 4 alpha 3 is equated to 0. And the second here you can see 2 alpha 1 and plus alpha 2. Here 6 alpha 3 is equal to 0. And the third 3 alpha 1 plus 5 alpha 2 and here plus 2 alpha 3 is equal to 0. So by simplifying, you can understand that by elimination method, you can understand if all the alpha i's are 0, then you can say that is linearly independent. If alpha i's are not all 0, then you can say that is linearly dependent case, right? Or you can use the determinant method. So the determinant method here 1, 2, 3, 4, 1, 5, minus 4, 6, 2. So 1, 2 minus 30, minus 4 into 4 minus 80, minus 4 into 10 minus 3. So here it is minus 28, then plus 56, then again minus 28. Yes, minus 56 plus 56, which is equal to 0. So this is linearly dependent vectors. So this set of vectors is linearly dependent either by doing these steps or you can use the determinant method. But one of the important thing while you are doing the determinant method, the set of vectors you have to write in vertical mode. If you properly written like 1, 2, 3, that is horizontal mode, the result may vary. So don't use this method. Use the vectors in vertical mode so that if it is equal to 0, it is linearly dependent. Not equal to 0 gives linearly independent. Now you can see the third problem, which is equal 1, 3, 4 and 1, 4, 3, which is the subset of P3 of vector space over R. So this set of vectors we couldn't able to do in determinant method because here there is only two set of vectors which is a subset of 3. So it is not sufficient to do the determinant method. So that you have to use the rank method. That is 1, 3, 4. Here also you have to write in the vertical mode. Then 1, 4, 3. So which is equivalent to 1, 1, 3 minus 3, 4 minus 3, 4 minus 4, 3 minus 4, 3 minus 4, right? So which is equivalent to 1, 1, 0, 1, 0, then minus 1 plus 1, 0. So from this you can analyze that the rank is equal rank of this matrix, that's equal to number of non-zero rows, which is equal to 2. And you can verify that which is equal to the number of columns. So if rank is equal to the number of columns, then that is said to be linearly independent. So a result is there if rank is equal to number of columns which gives a linearly independent, and if the rank less than number of columns, which gives a linearly dependent. And so we have another results that empty set is always linearly independent. And you can see if any two of the vectors are equal or it is a scalar multiplication of the other, we can say that is linearly dependent. Again, we see in the very first result, if any one of the vector is a zero vector, then that is said to be linearly dependent. And and if a rank is equal to the number of columns, which gives linearly independent, and if rank less than number of columns, which gives linearly dependent. So empty set is linearly independent and zero vectors is linearly dependent case. Thank you.